nanometers down to about 1 nanometer. We noticed a blue shift particularly for particles smaller than 5 nanometers in diameter, where there is a shift of about half an electron volt. We also see such a shift for the bulk plasmon resonance. In this case, the magnitude is a bit smaller, though, about 0.1 or so electron volts. Okay, so how do we explain this blue shift? Well, classically, what you may want to do is use a damping term. So gamma represents the scattering frequency of electrons as they're traveling through the metal. And generally what you would do is kind of modify this bulk scattering frequency with a term that's proportional to the Fermi velocity of electrons as they travel through the metal and inversely proportional to the radius of the particle. So this term would account for the peak broadening that we see quite well, but it actually predicts a redshift for surface plasmons in noble metals. So instead what we did is we used the quantum approach. As you know from your inorganic chemistry classes, molecules are composed of a discrete number of atoms, and the density of states is therefore also discrete. So, of course, our largest particle has a large number of atoms on the order of a few hundred. But what we can do is model all of the possible allowed transitions between these very closely spaced discrete states, where electrons can basically undergo transitions from filled levels below the Fermi level to unfilled or unoccupied levels above the Fermi level. And if you sum over all of the possible allowed discrete transitions, accounting for the fact that electrons are basically confined to a spherical potential well, then you wind up with a surface plasmon resonance or an absorption efficiency that looks a lot like this. So here's the absorption spectra plotted as a function of particle diameter, where the color indicates where you'd get a peak in the resonance. So this is our simple analytic quantum model. We can overlay our experimental data on top with basically no fitting parameters except for accounting for the substrate. And you'll notice it